All right, in this video, we are talking about the binomial distribution. So, our example says a hotel has 4 elevators. One of them is a freight elevator. When passing the button, one of the elevators randomly surfaces your floor. If you use the elevator 7 times, what is the probability that you use the freight elevator exactly 4 times? So, first thing, how do I know this is binomial? Well, we check BINS. So B, is it binary? Are there 2 outcomes? So what are the 2 outcomes? Well, my question was about, well, what's the probability that you get the freight elevator? So we get the freight one or the regular elevator. Okay, I is each trial is independent. So every time that you push the elevator button, is everything independent. So if I get the freight elevator the first time, does it matter or does it influence whether I get the freight elevator the second time? Nope, it doesn't. So they are independent. N, is there a fixed number of trials? How many times am I going to call for an elevator? It says if you use the elevators 7 times. So I'm going to call for that elevator 7 times. And then S is the probability of success, which really is that P. So is the P the same every time? Well, there's 4 elevators. One of them is freight. So the probability of getting the freight elevator is 1 out of 4. All right, so does it meet BINS? Yes, it does. That means it's binomial. So I want to find my N, which we just decided was 7, and my P, which we just decided is 1/4. And I care about the X, and it says exactly 4 times. So I am really finding the probability that X equals 4 because I'm asking, does it show up exactly 4 times? So to do this, we can use that big formula, or we can use the calculator. And I'm going to show you how to do it on the calculator. So we go to our NumWorks calculator. And we want to make sure we go down to our distributions menu. We've got binomial. My number of trials is 7. My P was 1/4. So notice how if I type in a fraction, it turns itself to a decimal, and that is fine. So we hit enter. Now over down here on this left-hand drop-down menu, we need to pick the direction. So am I going something less than, an in between, a greater than, or this last one is exactly? And I need exactly 4. So I choose the last one, and then I change my X value to be 4. And the probability I get is 0.058 if I were to round that correctly. So back over here, I've got the probability that X equals 4 is 0.058. And then if I were to write a sentence about this, I would say the probability that a freight elevator is called exactly 4 times out of 7 tries is 0.058. All right, the next thing that we talked about in class with this rule was how to graph these things. So when we are graphing them, we need to know the probability for all my X values. So we start with the probability that X equals 0, and then X equals 1, and then X equals 2, all the way down to the probability that X equals 7. And we stop at 7 because up here N was 7. Oh, I'm running out of space here. Oops. Okay. Probability that X equals 7. All right, now I already know the probability that X equals 4 is 0.058. And then I would come back to my calculator, and now I just change my X values. So if I change it to 0, I got 0.133. So then I come over here and I point this is 0.133. And then I go back to my calculator and I change it to the 1, x equals 1. And then I get 0.311. And then you do that for all of my different x values. So instead of doing that right now on this screen, I'm just going to write down the numbers. I already found them. But the one that I do want to talk about is number 7, because that one looks a little funny. So when we type in x equals 7, you will see over here that you have this e to the negative 5. Another reason why this would be funny is because you've got this whole number there, and you can't have a probability that's bigger than 1. So that should be your first indication that something's wonky. All right, so this e to the negative 5 means you need to take this decimal and move it 5 spots to the left. So really, this is going to be 0.00006. So we need 4 zeros in front. So to get my 4 zeros in front, I'm going to have 0.00006. All right, now we go ahead and we can graph it. So when we graph it, we're going to have the number of freight elevators on the bottom. And then this is the probability of the number of freight elevators going up the top. So my smallest number of freight elevators that could have been called is 0. And then 1, 2, 3, 4, 5, 6, and 7. And now I look at my probabilities and I figure out, all right, which one is my highest probability? And right here, my highest probability is 0.311. So I can skip count by 0.05s or I can skip count by 0.1s. I think we're going to go by 0.05s right today. So here's 0.05 and then 0.1 and then 0.15. The most important thing is to make sure that you are skip counting correctly. That's a 2. 0.25, 0.30, and then 0.35. And then I just go ahead and make my bars. So my first bar for x equals 0, the probability that x equals 0, I have to go all the way up to 0.13. So that's roughly here. All right. Are these going to be perfect? Nope, they're not. But they're going to be close. All right. My next one goes all the way up to 0.31. So that's slightly above my 0.3. And I do this for each of them. My 2 is the same. So you can either make your bars touch or you cannot. That is totally up to you. Just keep it consistent. So you can't have some bars that touch and then some bars that don't, because that's not okay. All right, now that I'm down to number 5, it's like 0.01. So 0.01 is like really close to the bottom. And then I got like 0.00, which is like even smaller. So I'm just going to draw my line right there. Just indicate that there is a probability there. It's just like super, super small. All right, the next part of this is to describe the shape of my graph. And if you notice, it kind of goes up and then comes way down. And it goes down and to the right, which means this is skewed right. So to write your sentence, we would say the distribution of the number of freight elevators that are called is right skewed.